Hello everyone, welcome to this video, and in this video I am going to take the concept of capacitance for grade 12. Remember the first chapter that you studied in the 12th grade, electric field and electric charge, and the second chapter that you studied, which is electric potential. So we are going to have a concept that is capacitance, which contains both the concepts together, right? So now we will understand in this video what is a capacitance and how a capacitor is made. We all must be wondering, what does this capacitor do? How does it actually store charge? So in simple terms, to tell you in simple terms, I would say that capacitor is a device. It is an electrical or electronic device. I would say electrical device. It is an electrical device which helps you to store charge. Okay, it helps you to store charge. And how does it store charge? With the help of the electric field in the medium. Okay, it takes the help of the medium, it takes the help of electric field, and it helps us to store charges. Now let me take you to the whiteboard and let me make you understand how a capacitor is made. So basically it's a device. Now I will show you a parallel plate capacitor, and I will show you how a parallel plate capacitor comes into existence. So let us get into the screen share. Now you know that a parallel plate capacitor will have two plates which are parallel to each other. Plate number 1, plate number 2. Okay, now you know that this plate number 1, I will name the plates, okay, you will understand it better. This is plate number 1 and this is plate number 2. Both the plates are neutral. Do they have charge? No, they don't have charge. They are just neutral. Then where are they storing the charge? Where is it they are storing the charge? That is what I'm going to show you. To make it active, I have to connect these plates which are parallel to an external source of voltage. Okay, I need to connect this to an external source of voltage, and you very well know that an external source of a DC voltage is a battery. So I connect this to a battery. Very simple, right? Okay, very simple. Now usually what does a battery do? Battery is used to run a current in a circuit, but here battery is not running a current here for me, students. The purpose of a battery is not always to run current. It is sometimes to create potential also, to create the potential difference. Current need not run, but it creates a potential difference. Of course, yes, in current electricity chapter that you learn that battery runs the charges, and because of which current is flowing, but not in every case. In this case, it is not used to run charges as current, but to transfer charges. Yes, it is used to transfer charges. Now you look here. As soon as the battery is connected, this is a positively charged, this is a negatively charged. So I told you it is a neutral conductor. It's a metal. Okay, it's a metal piece. Okay, it's a metal piece, so it's neutral. And metal piece, since it is a metal piece, it will have free electrons, right? Even in lower grades you have studied that metals have free electron. Now all these electrons are going to run. Where? These electrons are going to run towards the battery, and from there all these electrons are going to be accumulated at this point. So what is happening? Electrons are getting accumulated in one point and being removed from this side. So electrons are being removed from plate number 1 and being accumulated because of battery. So who's doing this running of electron? Who's causing this movement of electron? See, I'm telling you, it's not forming a current, but it is just doing a movement of electron. Because you know that for current you require a closed circuit, and this is not a closed circuit. Yes? You agree with me, isn't it? If you don't agree with me, put it in the comments. I'll be very happy if comments come with doubts. Now, when electron is being removed, you know that this turns into a positive charge. Okay, so plate 1 has become positive charge, plate 2 has become negative charge, and you should know that whatever electron is being removed from plate 1 is going to plate 2. That means both the sides are going to have same charge but in opposite magnitude. That means if 30 electrons, let us consider that 30 electrons are being removed from plate 1, so 30 electrons are being added to plate 2. So what is the charge of plate 2? Minus 30. And what is the charge of plate 1? Plus 30. So in plate 1 and plate 2 you will have same charge, but one will be positive, other will be negative. Understood? This is the reason why both the plates have same charge, equal charge. Why? Because the number of electron removed from the first plate is going to be the number of electron added to the second plate. So obviously charge is balanced here between the plates. One side becomes positive and one side becomes negative. So I will consider that this positive plate has a charge of positive Q, and similarly the negative plate, the plate number 2, has a charge of negative Q. And this setup is made only because of the battery. All thanks to the battery, because if battery was not applied, this setup wouldn't be possible. So I have applied the battery, and the battery has provided the charge. Now you should also know that the battery has a voltage of V. Yes, battery has a voltage of V. This battery has created a charge of Q in the conductor, and this whole capacitor arrangement also has a voltage of V. Why? Because battery is the voltage provider, so even the capacitor has same voltage as V. So now what is our capacitor having? What is my capacitance? What is the capacitor consisting of? My capacitor has a charge of Q and voltage of V. My capacitor, this capacitor that you are seeing, has a charge of Q and voltage of V. Now I can say that my capacitor is storing a charge Q. Look here, what is happening? Look at the capacitor. My capacitor is able to store a charge Q. Plus Q one side, minus Q another side. Right? So that is why I have a formula of capacitance. Capacitance is equal to charge divided by voltage. So charge enclosed in the capacitor divided by voltage of the capacitor. So in this case my charge is Q and my voltage is V. See, this is a general formula for capacitance. So this formula can extend to a spherical capacitor also. But now in my case I am doing a parallel plate capacitor. So of course this formula can be used for parallel plate capacitor, but I have to understand the specific formula. Now from here I want to create a formula. Okay, I want to create a formula, okay, only for PPC, parallel plate capacitor. I'm sure that you know the formula, but I need to show it to you how it comes and what is the background behind the formula. Now voltage is being supplied, right? The voltage is being supplied by the battery. Now you know that this is a plus charge and this is negative plus Q charge, this is minus Q charge. You know that electric field starts from positive charge and ends in negative charge. So here I have my electric field between the plate. Now when the charges are created, electric field is also created. This is the logic. Now my capacitor has electric field between them, and the magnitude of electric field is E. Understood? My capacitor, see, you understood how this capacitor is being made. plus q, how plus q came, how minus q came. Now let's go back to electric field concept. I know that electric field starts from positive charge and ends in negative charge. So I have a positive plate and I have a negative plate. So there will be parallel electric field lines which are going from positive plate to negative plate. So now I have my electric field also. So now I told you that this whole capacitor has voltage V. Now let me consider that the distance between the two plates is small d. The distance between both the plate is small d. So from the formula of electrostatics, my E is equal to voltage by d. So with this formula, I can even calculate the electric field value that is present between the plates. So if I want to calculate the electric field present between the plates, voltage divided by the distance between the charged plates. That will give me the formula, isn't it? This is going to be providing me the formula for this, right? Now what I can do here is I need to find the capacitance value, right? Here I need to find the capacitance value. Now let me recall one more formula for you, okay? And that formula is electric field due to a electric field between two oppositely charged surfaces, surface charges. That means, or I would say oppositely charged plates. So remember students, you have learnt this formula in one of the application of Gauss law, okay? In one of the application of Gauss law, if there are two plates, one is positively charged plate and other is negatively charged plate, and this is the electric field between them. So the electric field value is found to be epsilon by sigma by epsilon naught. Please recall this formula. I'm sure that you know this formula, because electric field due to one plate is epsilon by 2 sigma by 2 epsilon naught. Other plate is also sigma by 2 epsilon naught. Since they both are in same direction, it need to be added. The electric field, to find the electric field, they both need to be added and you get epsilon naught by sigma. So my electric field from here, my sigma is surface charge density, which is Q by A. Do you remember this? My surface charge density is Q by A. We have to go to the Gauss law. If you are not understanding how is this formula coming, I want you to visit and understand Gauss law. I want you to understand Gauss law. Once you understand Gauss law, you will understand how did this formula come. So from here, E is equal to Q by epsilon naught A. So now this E I am going to put here. So from here I would get V is equal to Q D by, okay, Q D by epsilon naught A. And you very well know that epsilon naught is the permittivity of free space. Why? Because now between the plate it is only free space. If it is something else, then the story will be different. For that, if you want to understand about that, if you want me to take a class on what happens if I introduce a new medium between the capacitor, please try to put the poll, okay? I have a poll in the description where I'm asking what should be your next class about, and I have included that. So please do vote if you want me to take the class on that topic. The next 12th video should be on that topic if you want that. So please do take part in the poll. Right, so now I have got my V is equal to Q D by epsilon naught, and now this V I am going to substitute in this formula, the final formula. So now Let me see. C is equal to Q by V. So it's going to be Q by QD into epsilon naught by A. Now the capacitance of a parallel plate capacitor Q will get cancelled is epsilon naught A by D. Now this is the value of capacitance of a parallel plate capacitor. So right now look here, you are looking at a parallel plate capacitor here, and now I have calculated the value of capacitance for the parallel plate capacitor. So the parallel plate capacitor, the capacitance depends on the area of the plate. See, there is a plate, and that plate will have a surface area, right? It depends on the surface area of the plate and the distance between the two plates. That will give you the area of the parallel plate capacitor. Now look here, since there is air between the medium, between the two plates, I am just putting epsilon naught, which is the permittivity of free space or permittivity of air. But if at all I am putting some other medium, then the formula will change here. In place of epsilon naught, I need to find epsilon for the new medium, a new dielectric medium, right? Or if I am putting conductor, then again the formula of epsilon naught will change, right? So that is a topic for next discussion. So I hope you have understood the concept that has been taught today. So it was very simple. I wanted to keep a very simple concept, that understanding capacitors and how a capacitor is being created, how a parallel plate capacitor comes into existence. So depending on the poll that you are giving, depending on your suggestion, my next video for 12th grade is going to be, right? So that full freedom I have given to my students, so they can choose what should be the next topic they want to see. I hope this particular concept is clear to you. You will never forget the concept of capacitance which I showed you today, and you will remember how the capacitance works. So my target is to make the difficult concept in physics very simple for you. Let it be 9th, 10th, 11th or 12th grade. No physics is going to be tough for you, and I'll make sure that it is not tough for you. So with that, I will end today's session. We will see in the next session with videos for other classes. So please do participate in the poll and tell me, suggest me what should be the next topic that I should be making the video on. So until then, goodbye students. Adios.